Here we have the WB200. It is about 4 by 3. What we have is 7 terminals at the bottom, 2 for power, 2 for sensor, and 3 for your Form C relay. Your power polarity matters if you're using DC voltage. Your sensor polarity will never matter. Your Form C relay will not detect if you have wires connected or not, and will trip both normally open and normally closed at the exact same time. Alright, we're going to be applying power to the WB200 using the 12 volt DC kit that comes with a pigtail. So first we're going to validate that we have power using our multimeter over here. So we're going to switch this over to DC. And we're going to connect this DC. And then validate that we have voltage. And now we have 12 volts. So our adapter is working. Now just for reference, the WB200 is in an alarm when there's no voltage applied, meaning that you will hear the relay click when voltage is applied. So we'll connect it first. And again, polarity matters when using DC. And once we apply power, you will hear the relay click. Alright, we are going to be applying the WSU. Now remember, polarity does not matter. The WSU does come in a red and black lead from the WB itself, but polarity does not matter. The WSU is approximately 2 inches by 3 inches and about 3/4 thick. It will tell you up on top it's a WSU, but if this sticker has been removed or you can't see by the end of the line, you can check with a multimeter to see if this is an open. A WSS, however, will have a 1 meg resistor. If the system is dry, this should show completely open, and if this is wet, regardless of power or not, you will see an ohms change on the system. So we'll switch this over to ohms, and we will connect directly to the unit. And again, polarity does not matter. And we will see that we have an overload or an open condition. When tying to the WB, polarity does not matter, so either way works. Now, if you're tying this to an alarm panel, you need to ensure that you're connected to your outputs. But to make sure that this is working without actually tying to an alarm panel, we're just going to short out between here to see if we can get a trip. And you can hear that click. Now it's important to note on the WSU that the wire coming in actually branches out. So one wire goes down this avenue, the other wire goes down this avenue. A bridge has to be made between the two wires to make a proper contact, meaning that a short or a water detection between this is an alarm, between here is an alarm, same as kitty corner and catty corner. As well, if you try to short or get water between these 2 points, it will not detect an alarm. Alright, so we have one WSU, and what we want to do is have 2 WSUs, so we can either put the wiring in the same, or we can extend the wiring and then using a splice, which is what we'll be doing. I prefer to use this as it makes it easier to run and easier to troubleshoot. These terminals here are not large, and you will have a difficult time adding more than 2 sensors. Here we'll be using our Wagoos as an extenders. These are 221s. Very easy to work with. And we'll simply just put one on each one. Now we'll grab another WSU. And we will line up the same colors just to make it easier for troubleshooting again and wire runs later down the line. Now you'll want to make sure that each one has latched in. So give it a gentle pull. Now you have two running in parallel, and if either one goes into alarm, the relay will trip. So we'll go ahead and test that to validate. And again, if you short or make a contact between these will not trigger. But between the two shorter ones will. So you'll hear the relay click, and the relay will click again. We are going to talk about the Form C relay. Now we can either have the water bug connected or not. It depends. If you're getting a bunch of false alarms, you may want to disconnect this to isolate whether you're having problems with the WSU or with the controller. If you do not have direct access, you can disconnect here and actually just short in the terminals, which will simulate water to validate whether, again, you're having a problem at the device level or at the sensor level. In this case, I will go ahead and connect this in, and then we can test the Form C relay. I'm going to be connecting between common and normally open. Again, the WB200 does not detect whether or not you have wires connected. You can do this either as a normally closed connection or a normally open, and it only based upon what wires you're using. Since we'll be doing common and normally open, we'll be connecting to common and normally open. We'll be switching this over to ohms. You can do continuity, really up to you how you want to move forward. Now, currently right now, common and normally open is showing OL on the fluke meter, which means open. Your multimeter may show differently. We're going to first test to validate that the system is operating properly by disconnecting power. You can hear the relay click, and now we're showing ohms because it is a short. Applying power. The device is working properly, and now we will test the sensor to make sure that it is detecting by shorting between the two closest. So we will short here, and we'll see a change on the multimeter as well as the relay click. In this next video, we are just going to be showing how to add either a solenoid valve or a piezo buzzer. Both will do the same. Now, the Form C relay here is a dry contact, meaning there is no voltage by default going through. We have to make an actual circuit. This is rated at about 1 amp and 30 volts. And to make this work, we're going to have to, again, make a circuit through. Most people would use common and normally open, but it depends. If you want voltage constantly, you would be tying to common and normally closed. And if you want only voltage when you are in an alarm, such as a piezo buzzer, you don't want to go consistently going, you will be going between common and normally open. So to make this work on the multimeter, we're going to switch over to common and normally closed. And here we have a BZ1. This is no longer manufactured, but you can use any piezo buzzer. Now, I typically like to validate this is working prior to getting the incorporation of the water bug. Now, you can simply do that just by going on top of the connections. And you can see that we're getting voltage and sound is coming through, meaning that this is working. Typically, polarity does not matter on this system. So for this to work, we are going to disconnect power for now. We'll see our relay is now open on the common and normally closed side. On the other side of this, we are going to go to normally open. And even though this is in an alarm condition, since there's no voltage going through, the piezo buzzer will not work. It's also important to note that even if it was in an alarm with power with this setup currently, it will not go into an alarm. We have not completed the circuit. And we will go ahead and validate that. We'll apply power. We'll see that the system is closed between common and normally closed, which would imply that between common and normally open is open. Since this is a dry contact, this will not go into alarm just because this is being shorted out. So here we have the system now in an alarm, and we have no power going through. To make voltage go through here, we need to have one jumper wire between the ground and common. Now we have a common, which will this complete the circuit. So our positive is coming through the system, going to our normally open contact, which is not which has a break. So this is an open circuit here, and goes back into the negative or the ground. Once the system is powered on and there is a short, now this system will activate. So here we have our common and normally closed is showing as a short. And again, we'll just do a quick validation.